Hi, I'm Mike Bush.
I'm Paul New.
And I'm Colleen Sterling. Welcome to Ask the A&Ps from AOPA.
On Ask the A&Ps, you try to stump us with your hardest maintenance questions, and frequently you do. but once in a while, we actually come up with answers, and you get to see how we develop them in real time, which is sort of fun. So if you have a stumper or a semi-stumper, we would love to have you on the show. Just email your question to podcasts@aopa.org for a chance to get on the show and have a little fun with us.
And I will advocate for some softball questions, just to put that out there. But please follow and subscribe to be alerted when the next show comes out so you can see what we get right and wrong.
And if you'd like to get on our email list for our monthly newsletter and other good stuff, easiest way to do that is to text the word SAVVY, SAVVY, to 33777, and a little bot will pop up on your phone, ask you for your name and email address, and add you to our mailing list. So just text SAVVY, SAVVY, to 33777 to put yourself on the list.
So I'll jump in here. I got an interesting email yesterday. A new to me customer. It makes it more interesting when it was yesterday. This was not 2 weeks ago. But anyway, a new to us customer bringing his airplane in. And the email said, looking forward to being there to start the annual a couple of months from now. And basically saying that, oh, and by the way, I've ordered a new engine for the airplane that should be there a couple of weeks after the airplane gets there. And then he goes on to explain his current engine has over 2,000 hours and, all the normal, I fly the family in the airplane. I want to be sure I get ahead of it. And so I've proactively purchased this engine to be safe and all that. And then ask, what do you think?
And I hope you didn't tell him what you thought, Paul.
Well, no, I did. I was very careful because this is not the first time I've had these kind of statements. But it was, my head explodes with all these questions like why and all that. So, of course, anyone that listens to the podcast can imagine all the things that I said, but I was concerned that he had not thought about all the peripheral things that an engine change kind of automatically sets in motion. So I just listed those out.
An overhaul, you have to replace certain items or overhaul certain items along with it.
Right. Certain things on the engine, of course, but he's purchased an engine. So this will be an exchange, but also all the things like, have you considered engine mounts, flexible hoses, baffling repairs, all these things that it's not just the engine that gets swapped out. And
is this a Cirrus?
It is a Cirrus, yeah.
Is it a turbocharged Cirrus or a normal?
It is not, fortunately. So that helps.
So that lowers the number of
things. Lowers the number. But I mean, he didn't ask for an estimate of how many hours it was going to take, that sort of thing. And of course, then being me, as nicely as I could, I tried to explain the reliability. The 2,200 hour engine being so much more reliable than the zero time engine. And he had already thought through all that, but I didn't know this at the time.
What was wrong with the old engine?
It was old, Mike. It was past TBO.
It was past TBO.
Like an airline pilot.
And
Gotta go.
he was good to go past TBO by 200 hours. But he was thinking, and he said something to the effect of, well, I'd rather go ahead and do it now than maybe squeeze another couple of 100 hours out of the engine. And I'm thinking maybe another 1,000 hours out of the engine or more. But anyway, it just kind of took me by surprise. So,
Yeah, I totally understand that because in my youth, I went through the same experience. I bought my present airplane, my Cessna 310, in 1987. It was my third airplane, and I bought it with the engines almost run out. They were 100 hours from TBO, and after consulting with as many wise friends as I could, because at the time I was not an A&P myself. I was just an appliance operator. But they all said, well, just keep flying them until they start to give you trouble. So I cruised on up to TBO, watched the Hobbs meter flip, and expected a whole bunch of clowns' faces to come up on that Hobbs meter, when the engine just like quit cold.
Did the engine sputter or anything when that happened?
They did not do that. I
Wow.
sputtered, but the engine did not sputter. And I continued flying that airplane for another couple of years until the engines were at 500 hours over TBO. And then, I don't know, I just was having trouble getting to sleep at night. It was like, Mike, you've sort of pushed your luck quite a ways, but maybe you shouldn't push it any further. So I decided to pull the engines. I hired an A&P, and the two of us worked to pull the engines and stick them on the back of a pickup truck and drive them down to the best overhaul shop in Southern California at the time, Lynn's Aircraft Engine, and had them. I asked him to overhaul the engines, but I said, after you've torn the engines down and gotten all your measurements and everything, and before you start building them back up, I'd like you to call me, because I'd like to come down and survey the damage and see what these 500-hour over TBO engines look like inside. And so a few weeks later, I got the call, and I drove down to the engine shop, and my engines were on two big roll-around carts in little pieces, with clipboards and measurements and all sorts of stuff. And I was floored at what I saw. What I saw was an engine that was basically in pristine condition.
Yep.
And the cylinders were all within a thousandth of new limits, not just service limits, but new limits. Right. The cam was perfect. The crank was perfect. The bearings, didn't look particularly worn. It was just obvious that those engines could have gone another, 1,000, 1,500 hours without breaking a sweat. So I went away from that experience. First of all, it turned out to be really, really cheap overhauls, because we reused all the same cylinders. We just revalved them and gave them a light hone, slapped them back on. And, but I went away from that saying, well, I'm never going to make that mistake again. And that just, that sort of put me on this path of saying this TBO stuff is complete, utter nonsense. So
interesting. When I talk to, a lot of customers who call me when I do events for COPA or Cessna Pilot Association or CART, any of those, there's always someone that asks about, well, I'm getting close to TBO and I should do this because, I fly my family in the airplane. So my question is always, what is it that you're concerned about? Mm-hmm. And they never know. Mm. They don't know. Well, because it's always because it's at TBO. And I said, well, who has told you that something dramatic happens when you hit TBO? And they're like, well, I just assumed. I said, or maybe they've talked to their mechanic or to their engine shop, whichever. And I said, well, go back and ask that person, whoever it was that put this concern in you, what specifically they're expecting to happen. What bad thing is going to happen? And then let me know, and I will tell you how that can be monitored in real time.
Right.
Instead of just changing it, thinking that, well, maybe it's a problem.
They should make a data-driven decision, not
yeah.
Not just based on
two things that we know from very good analysis of the data is first of all that there are very, very few engine failure related accidents involving high time engines and a lot more involving low time engines. So
Right.
the time to be worried about an engine is when it's young, not when it's old.
Yep.
Yeah. Or an
And the
old
second
engine
thing
that
is
just had a top overhaul.
And the other thing is, well, yeah, and in fact, the accidents involving high time engines generally are maintenance induced failures due to the
Right.
fact that engine had cylinder work done or something, and somebody didn't torque something up right. But it weren't actually related to the fact that the engine was high time. But the other thing that we know from the data is that the sorts of failures that you have are different in low time engines, in young engines, than in old engines. Old engine failures generally are ones that give you lots of warning if you are paying any attention.
Yeah.
The engine starts making metal,
Yeah.
The oil consumption goes through the roof, various things that sort of say, hey, I'm starting to get sick, I need some help. Whereas the engine failures that happen with young engines are typically catastrophic things that happen with no warning whatsoever.
Yep.
Remember we had a rash of crankshaft fractures back in the 90s.
Mm-hmm.
And because there turns out that there was a manufacturing problem with a bunch of crankshafts. They had bad metal in them, or they had a machine that was putting a stressorizer in them when it.
And all of those could arguably be considered a maintenance-induced failure,
Or parts.
Or
Parts that are like
but
the
the point is that they're of different character. The failures that happen with no warning and no way of detecting that something is happening in advance are much scarier than ones that give lots of warning.
Yep.
So, Colleen, you did your engine overhaul.
I did 2 engine overhauls where the mechanic said, well, the cylinders are getting tired. We should pull the cylinders. And then you go down that slippery slope where it's like, well, you should just do an overhaul.
Right.
So I had that experience twice. And both times the engine looked great inside.
So when a mechanic says the cylinders are getting tired, I hear that a lot. I also hear owners that say, oh, the engine is running strong. And I have no clue how they measure the engine is running strong. But when your mechanic said the cylinders are getting tired, do you remember what they were implying?
Yeah. Well,
what did you infer?
The first time was when I was a new owner back in 1992. And we did our first annual, and one of the cylinders was 60 over 80.
Oh my God. And you survived?
And we didn't know the difference. And instead of, flying it and trying it again or lapping a valve or figuring where the air was going, the mechanic said, well, you're at 1,700 hours and the airplane's new to you. You don't know how it was operated before. I would recommend just doing an overhaul. I think the cylinders were all original. I don't know. And, we were flying over the Sierra Nevada mountains a lot, and we felt like we wanted a clean slate. And it reminds me of people who like to lease a car, right? They like a new car every.
Right.
I don't. I think sorry, Mike. I think that's a waste of money. And I like to drive a car until the maintenance is not worth, the inconvenience of all the maintenance and costs is not worth it. And then I get a new car. That's usually
what Helen does.
To 12 years. And I feel like I got my money's worth out of it, and I'm comfortable with the car. I don't need that new car smell, and I don't need that new engine smell on my engine either. Yeah. I would rather fly with the engine that I know. And I have done an overhaul and then got the new engine in the airplane, and then things weren't the same. It didn't operate the same. Other things went wrong, and I really regret, having pulled the trigger on my old engine so quickly. Yeah. Our first question is from Ken, who wants to do some mitigation on some vibrations he's getting. Go ahead, Ken.
Hi, good afternoon. Great to be on the show. So I fly a 1962 Piper Cherokee, and I've noticed over the last few years I started to get some vibrations in the engine at a particular throttle setting. I've flown this airplane for 6 or 8 years. It never really experienced it until about 2 years ago. I also didn't have an engine monitor until about a year ago, so I was limited.
Oh, that accounts for it right there.
There you go. It was saying, please help me.
Yeah, it's been a wonderful tool to have in the aircraft, and it's allowed me to do some real good data collection on this issue. The issue was max power climb. Airplane flew just fine, no vibrations. I pulled the power back to cruise setting, and as you pass through about 90% throttle position, the engine would begin to vibrate, and that vibration would transmit through the airframe. I also get a little bit odor of combustion gases, probably the things shaking and rolling. But it wasn't until I got the engine monitor I started to troubleshoot this a little bit more thoroughly, and discovered that if I left the throttle position at the 90% location and sustained the vibrations, I was able to suppress them with leaning the mixture. What was more interesting is that with the engine monitor in front of me, I could tell that one of the cylinders was coming offline. And as I leaned the mixture, the cylinder came back to life and started producing power again, and the EGTs would smooth out. So between that observation,
well, let me ask a couple of questions here. When the engine was running rough as you pulled the power back through 90%, first of all, where was the mixture control set? Was it full rich? Mm-hmm. And what altitude are you at?
I'm a sea level flyer, so this happens anywhere. Anytime I level off between 0 and 6,000 to 8,000 feet.
Because you can't be at 90% power at 6,000 to 8,000 feet.
90% throttle.
Throttle setting, yeah. So this issue seemed to trend with a physical location of the throttle knob.
Yeah. Well, I mean, it sounds to me like you're not leaning in the climb, and so the engine is probably horrendously rich, and the reason the cylinders are going offline is because they've got a mixture that's too rich to burn.
Okay.
And then when you pull the mixture control back, you're bringing it back at a reasonable range. But I don't know if you've ever watched any of my leaning basics video or anything like that, but there's only 2 times that the mixture control should be full rich. One is when you're starting the engine cold, and the other is when you're taking off from a low density altitude airport at basically full power. But you definitely can't leave it rich, and as you climb, you have to lean it to account for the fact that the air is getting less dense as you climb.
And what I found interesting is if I continued to pull the throttle back to a normal cruise setting, the engine would run fine again, even at full rich mixture.
So what engine is this?
It's a carbureted 0320.
Oh, yeah. It's Cherokee 160. Okay.
160.
Yeah. Mm-hmm.
So I'm just curious because I don't know. I can't remember. I haven't done a lot of Lycoming work in the last 10, 15 years. Does this carburetor have an accelerator pump like a Cherokee? I mean, a 182.
I think it does.
So it's an enrichment circuit is what I'm saying.
Mm-hmm.
Mm-hmm.
So when you pull the mixture back, so when you're getting ready to do this, and you say if you pull the mixture back, you feel it change as well.
Mm-hmm.
Is it running okay with everything full forward? And then you pull the mixture back and you feel the same rumble?
No,
correct.
I don't.
Yeah, typically my approach is full throttle climb, full mixture rich climb. When I get to top of climb, I'll reduce the power from full throttle to 2350 RPM, and then I'll pull the mixture back to as lean as I can.
Yeah, he's too rich.
Yeah, you're
Yeah.
way too rich. Yeah.
Yeah.
Yeah,
Okay.
you're
Mike's
losing
on
a
it.
you're losing a cylinder because it's drowning in fuel, basically.
Mm.
Yeah, definitely step lean as you go every couple thousand feet.
So-
Bring that mixture back.
Well, you have an engine monitor, right?
I do now. Yeah.
So
So,
lean to
so if you lean in the climb to keep the TIT more, not TIT, EGT,
Ooh, a chair
Sorry,
quick
I had
test with
turbo.
TIT. I want
to
that airplane.
keep the EGTs more or less constant.
right.
Okay.
The EGTs will want to go down as you climb, and if you just keep pulling the mixture control back to bring them back up to where they were, that'll keep you more or less in the ballpark.
Yeah.
Yeah.
Okay.
Just pick one. You don't have to watch all four. Just
Yeah.
pick one that's easiest and keep it
Yeah.
there.
Okay. I have a follow-on question about EGT since I've been staring at it a while. I have one cylinder. The one cylinder that stopped producing power in this scenario is number 2. And number 2 is consistently running cooler than the other 3 cylinders, which to me infers that it's running richer than the other 3 cylinders.
Could
By
be.
about
Not necessarily,
Not
No,
necessarily. Yeah.
but
It's
it's easy to find out.
Yeah.
Yeah.
Okay. My EGT differential in cruise is about 125 degrees.
Doesn't
And in
matter.
climb.
That's not meaningful.
Yeah.
Okay.
It's where
We don't
they're
care. We don't care what the EGT differential is, but what
Okay.
would probably be a good thing. Uh-oh.
Colleen?
We lost Colleen there.
sorry.
Uh,
My rabbit just chewed the wire on my
Uh-oh.
light.
Oh no.
geez.
My lights. Oh my God. Anyway, sorry.
But what would be a good thing for you to do is to do a gammy lean test to try to determine what your mixture distribution is. It's not going to be great because it's
Yeah.
a carbureted engine, but Lycoming 0320s typically have fairly decent mixture distribution.
Okay.
But it would be good to do that because if it turns out that one of your cylinders is a big outlier from the others, that might suggest that you've got an induction leak someplace or a valve that's not lifting properly or something. But a
Okay.
gammy lean test is an easy way to determine how far apart your cylinders are in terms of what mixture they're running at. Ideally, they should be all running at exactly the same fuel air ratio. In practice, that never happens. But the gammy lean test tells you, how much of a mixture imbalance you have and which cylinders are the lean outliers and which ones are the rich outliers.
Okay. Is there a threshold beyond which I should attack a outlier cylinder?
Tack.
Tool.
Yeah, I know. Look at exhaust gaskets or intake gaskets because those have been serviced in the last couple of years. And the couplings, the intake tube couplings are new as well.
It could just be mixture distribution, right? It doesn't.
It may
have
be
to
that you just identify, yes, this is why this cylinder is the outlier.
Yeah,
Okay.
But you should really do my favorite test, which is just kind of geeky cool, is an induction leak test in flight.
Mm-hmm.
Yeah.
So wide open throttle at some altitude, 5,000 feet or 6,000 feet, something like that. Let all the EGTs stabilize. And you don't have manifold pressure, do you?
I do have manifold pressure actually.
Oh,
you do?
Oh, wow.
That's awesome. Good. We're proud of you. That's great. So,
that didn't come with the airplane that way, right?
No,
that was an option on the engine monitor.
Yeah.
nice.
I love it. So note your manifold pressure. Hopefully it's like 21, 22 inches, something like that. And then maybe it'll be 23. So pick 5,000 feet, something where you can get 23, 24 inches of manifold pressure. Let all the EGTs stabilize, note what they are, and then reduce the throttle by about 6 or 7 inches of manifold pressure. Let the EGT stabilize again and see if they all go in the same direction and in about the same amount.
Okay.
So if you have a leak in your induction system on a normally aspirated engine, when you're wide open throttle, the pressure differential between in the manifold system, in the induction system, and the outside air pressure is minimal. And when you pull the throttle back, you create a much bigger difference in those two pressures. So if there's a leak, you'll have more leak with the throttle pulled back than with the throttle wide open. And that'll show up as a different fuel air mixture on the cylinder where the leak is.
Excellent. Okay. I'll give that a try.
Yeah.
And Ken, we will. I will send Ian a link for the show notes that explains this. That has an explanation of how to do the induction leak test from Savvy's site. So
awesome.
You didn't have to capture all that writing it.
Yeah, start furiously writing.
Yeah.
But those are two fun tests to do.
Yeah.
Okay. I'll do that.
But do lean in the climb. Don't leave it full rich.
Okay.
Except, like I say, for cold start and full power takeoff are the only two times the mixture control should be all the way in.
Okay. When you lean in the climb, you'll produce more power on less fuel. So your climbs will be shorter, and you'll get up to that cruise altitude where hopefully you have wonderful tailwinds every time you fly. And
look forward to that.
Yeah.
And your engine will look cleaner under a borescope.
Yes.
And your valves probably won't be as inclined to stick.
Yeah.
The engine's been running really well. I do boroscopy and I lean aggressively on the ground. So strong disciple.
That's good. So
that
lean aggressively on the ground is good, but you should also lean in the climb.
Yeah.
Very good. I'll do that.
Okay. Well, great question, Ken. Thanks.
And we
Thanks,
don't have
everyone.
to give him the engine monitor lecture. So.
That's right.
Yeah.
He's already heard it. And he went over the top and got manifold pressure.
I think that's great.
It's been a great
that
school.
was a surprise.
Cool. All right. Thanks for calling, Ken.
Thank you. Take care,
Well
everyone.
done, Ken.
Yeah. Bye-bye.
Bye-bye.
Bye. Our next question is from Marcus, who has more of a technique question, but that's okay. We can do it. I almost said antique technique questions.
Technique or us.
That's right. What's up, Marcus? Good to have you.
Very, very good. Well, it's an engine technique question, so at least it's related. So I fly a Gen 1 SR22. We're with an engine monitor. We've got engine monitoring, of course, and we are also a Savvy customer. So thank you for all the help there. So my question is about leaning at altitude. During the climb, there's a clear fuel flow leaning schedule for us to get max power climb. The question I have is when we're doing either a takeoff from a high DA airport or landing at a high DA airport in preparation for a potential go around, what is the best procedure to set up the mixture for maximum power, either on the takeoff or the go around?
Well, I have a G1 as well. So this is what G1 owners do, Colleen and Mike. So what's your serial number? That's
24.
24.
Wow.
You do have an old
early.
187.
It's a Gen 0.5, I think.
0.5, Gen 0.5.
But Paul, you ripped all those round things out of your airplane.
Oh, yeah,
Put a bunch of square things in there.
Yeah, they're sitting on the shelf right out here on the other side of the window if you need any spares.
No, we've gone Avidyne, so we're
nice.
full Avidyne.
Okay, so the little chart that's on the instrument panel, it's okay, but a way better matrix is to use EGT, and we talk about that a lot. Your EGTs on takeoff roll, if the probes are put in the right place, are going to be around 1300 to 1350. And as you climb, just lean the mixture to maintain that EGT. And you'll come up sort of close to their chart, but instead of going 2,000 feet before you lean, this is a way to pretty much continuously lean. Mm-hmm. And if you get busy and you miss it for a few minutes, it's no big deal. You can always catch up. So do that for your climb leaning. Does the POH not have a procedure for high altitude airports?
I don't recall a specific procedure. I don't recall a specific procedure, particularly for the go-around prep. That's the one, because you can do a max power run-up if you really want to make sure you're at max power. You can do max power run-up, but for a go-around, you need to know where you want your mixture. So like when you fly into Tahoe's 6,000 feet, it may be 8,000, 9,000 feet DA. And if you have to go around on 1.8, you need to climb right now.
Yeah. Right.
Well, so what I do, and Mike has probably way more technical way to do this, but on my G1, I happen to have a fairly good idea at various density altitudes in my climb what my fuel flow is at that 1350. So at 3,000 feet on a 3,000 foot density altitude, I know my fuel flow is going to be about here. So for a takeoff at 3,000 feet density altitude or go around, same thing, I'm going to go wide open throttle, and then I'm going to lean to get somewhere pretty close to that fuel flow. And because I've already got the numbers, I don't have to sit on the ground and go full throttle and go through all that process.
So you're going to do that on the roll. You're going to do that on the roll.
Yeah. I'm going to throttle up, and before the airplane gets moving very far, you can move that mixture knob. It takes like a second. And you already kind of know where it's going to go, right? You're paying attention. Yeah. Oh, it's going to go by the X in the word mixture or something, wherever it is. You kind of have a thumbnail, and you start with the TLAR, and then you hone it after that.
Got it. Yeah, and fuel flow reacts fast enough that you can do that on the roll, I guess.
Sure.
Right.
Makes sense.
Right. And for people listening that don't have fuel flow in their airplane, they can use the knuckle method. Like, how many knuckles is it out? If you know your airplane after a while and you've adjusted it on the ground, you should be able to put it back to that area.
That's a very refined TLAR method. Very good.
Yeah, the other thing to keep in mind is that if you look at the horsepower curve as a function of mixture, when you're on the lean side of peak, the horsepower declines quite rapidly and linearly with reduced fuel flow. On the rich side of peak, horsepower doesn't change very much. The curve is very flat. And the point there is, it doesn't, when you're on the rich side of peak, you don't have to lean very precisely. You just have to be somewhere sort of grossly in the ballpark. Whether it's 50 rich a peak or 150 rich a peak isn't going to make any real difference in terms of power. It'll make a difference in cylinder head temperature, which you can sort out, when you have time. But you're not really worried about cylinder head temperature in a go around. You're interested in going around.
Yeah, right. I've
and
noticed
then
that.
Sorting the rest of it out later.
I've noticed that when you adjust the mixture on the ground at high power, you got to move the mixture a lot for 2 or 3% of power adjustment, right? When you're rich at peak, to your point, Mike, when you're rich at peak.
Well, and the main reason for leaning a little bit is because if you leave it full rich at 8,000 feet, the engine is just bogged. So you don't have to move it much to get a major improvement. That it's that first bit of movement where you get the big change. Like Mike says, once you're off of that, then it's pretty flat. Just get some leaning and you can tweak it. Yeah.
All right. Very good.
Serial number, you said 25?
24.
24. That's just.
Does he have you beat?
Oh yeah, mine's 187. Mine's
my God,
practically brand new.
That's practically a Gen 2. It's been a great plane. I've owned it for 3 years, and it's been a great plane. I transitioned to it from a 172 at about 100 hours total, 150 hours total as a private pilot. And
wow.
Yeah.
How was that transition? Was it okay?
It was good. I had a CSIP, local CSIP, who's fantastic, former military pilot, tens of thousands of hours kind of guy. And we went up and did some stuff that, I hadn't done in my regular private pilot training in terms of aerodynamic envelope, which was really good for me. And it's been a fantastic plane. It's great for.
Hey, Marcus, have you ever spent any time in the SR-22 simulator? Like
I have not.
Oh,
that's a really interesting experience because you can do caps pulls and stuff, and it's
oh, really?
it gets your
Oh, cool.
attention because that airplane goes basically straight nose down when you pull caps, and then after the line cutters cut, then it gets horizontal again. But it's a good thing to do in the sim because if you ever really have to do it, you don't want to be startled.
Yeah,
you're going to be startled, though. I'll bet
it's hard. It's hard to practice in the airplane, so it's a lot better to do in the sim.
Well, you don't need to add that shock to the situation you're already dealing with, right?
That's right. Yeah.
No,
Wow.
I've heard that. In my pre-flight briefing, I always talk about, should that ever happen, it's going to go nose down. Don't worry, that's how it's supposed to work.
Yeah. I imagine if you're pulling the chute, you're not going to be telling anybody anything at the moment. It's definitely going to be a pre-flight briefing. Yeah.
Yeah.
So that's what the line cutters do. They flatten the airplane out when it's under canopy.
Exactly.
Yeah.
Exactly.
Oh, wow.
Yeah.
That's important.
And there's a timer on them. I don't remember how long the timer is, but
it's 8 or 10 seconds.
Yeah, it's significant. It's a long enough time. There's a delay.
There's 8 or 10 seconds where you're in a very unusual attitude. I would hate to be a backseat passenger, going through that and not expecting it.
Interesting.
Yep.
Because they need the canopy to open, so they want high rate of descent initially until the canopy is fully inflated,
Well, and they don't want the canopy to inflate all at one time.
Well, and they want the load under the canopy pulling straight down while the canopy's inflated, rather than going sideways, which is what the airplane would do if it was in a normal attitude.
Huh.
Yeah, simulator seems like a great place to do that.
Yeah.
You bet.
Well, you can do it in your airplane, but only once.
Yeah. No, I'll pass.
Yeah.
Yeah. Well, I did that once in an SR-22 sim. I got to pull a handle, and it was like, I did not expect that. Wow.
Well, very cool, Marcus. Good question. You should go attend a CPP sometime if you haven't already with COPA.
Yeah.
I have not. It's on my list to do, though.
Definitely put that on your list of things to do. I like to encourage, I don't care what kind of airplane you have, if there's an owner's group to be a part of, you should be a part of it. And if they have events, you should definitely go.
Yep.
And as a serious owner, you should definitely go.
COPA's a great group.
Yep.
Really,
the COPA
really
website
excellent.
is so valuable. So valuable.
Yeah. And if you go to one of the CPPs on the east side of the country, I'll see you there.
Very good.
And do you party with the Cirrus people at Oshkosh? They usually throw a good.
They have a big party on Sunday.
Monday? A Sunday, yeah.
Sunday. Well, Sunday is the day that the three of us have to go to Culver's.
Oh, that's right. So we don't get to go. Yeah, but they're always having a big party over there.
No. I'm sorry. The COPA event is on Monday night.
It's Monday.
I said that wrong.
Yeah.
The Cirrus thing is on.
Yeah, the Cirrus thing's on Sunday. The COPA dinner is on.
Yeah.
Oh, right. I'm sorry. I'm mixing
I'm getting them backwards. No, that was me. So as usual. Anyway, go, Marcus. You'll enjoy it.
Yeah.
Oh, yeah. CPP and Oshkosh is on my list too. I haven't been there yet either.
Oh,
so.
totally.
There's
Oh,
I need to
my.
do.
Yeah. And be proud of that. Be proud of that serial number because those G6, G7 guys. Yeah. I'm 25. Be real nonchalant.
Yeah.
There you go.
Those guys are all appliance operators. They don't know.
Uh-huh.
All right, Marcus.
Okay.
Thanks for the call. It was fun.
Thank you guys. Appreciate the help.
All right.
Bye.
Our next question is from Luke, who is having a flap with his flaps. Go ahead, Luke. I didn't write that, by the way.
Okay.
Well, that's right. Hey, thank you all for having me on. Hey, so we're new aircraft owners, relatively. I've been flying for quite a while and do it for a living, but we're new owners here, and we've got a 1977 Cessna 182 Q model,
Q. Yep.
and
I had a 78.
yeah, it's
Yeah.
we love it. It's a great airplane, but we've just had this intermittent issue that's popped up several times, and once was it during the pre-purchase process during the test flight. Demo pilot went to go drop the flaps to demonstrate some slow flight and couldn't get them down for landing. So landed with the flaps up and checked everything that we knew to look at. Talked to a mechanic and to an A&P. No breakers tripped. Switch would move freely. You could hear it click when you're moving the flap lever down through the detents from 0 to 40, but the flaps just wouldn't operate. Previous owner had no issues with them. And about a week or two later, the broker was going to take the airplane over to a nearby airport to have a pre-buy examination done on it, and was just planning to ferry it over there with the flaps inoperative. And but he was able to get them to work. And then during the pre-buy, they worked just fine. The A&P cycled them probably 8 times, couldn't duplicate the issue.
Engine wasn't running.
So we brought the airplane home. We purchased it. We brought it home. Had no issues with it. Cycled the flaps, dozens of times. And then since then, we've now had the issue crop up again several times.
Yeah.
And
you never had a problem retracting the flaps. It's always a problem extending the flaps. Correct.
Correct. Yeah.
Is it always from the full up position?
Always from the full up position, yes.
Yeah.
And we'll be able to get them all the way down.
Yeah.
And then we'll be able to retract them after landing. And then the next flight, and again, it's only happened a couple times. One of them was actually with an A&P. We had serviced the nose strut and then couldn't get them down for takeoff, departing that airport. And he pulled off the inspection plate and he kind of moved some stuff around up there. He moved some wiring around up there and he was able to get them to extend. And put everything back together, and I was having no issues. But then, had the issue crop up once again. So, any ideas? We live across from a relatively short strip, and so we're kind of trying to avoid any unplanned diversions.
Yeah. Well, fortunately, this is pretty easy. So in the 182 class,
Luke, you came to the right place.
That's what I like to hear.
You're going to get a pinpoint diagnosis from the master.
I think I've heard that this is a fairly common issue from time to time. I'm curious your thoughts.
It's one of several common issues with the flaps. So, Carlene, I'm wondering, have you had flap issues on your Cardinal?
Is this a flap follower cable issue?
No, this is a switch and wiring issue.
I have not had that problem.
Okay. So, Luke, almost all of the single engine Cessnas have the exact same flap pre-select system, including the restart airplanes that are coming out. So 210s,
except for the real older ones.
If it has a lever where you can select an amount of flaps and then take your hand off and it goes there and stops by itself, that's the pre-select. So if you have that, and in the Cessna Pilot Association 2-day 182 class that we do, we spend about probably 15 minutes explaining how this system works. So this is going to sound a little confusing. There's 4 switches in the system. There are 2 out in the wing, and on your airplane, it's in the right wing. And those are the flap travel limit switches. They stop the flap. They're like the line of last defense, right? So when the flaps get all the way up or all the way down, it trips those switches. There are 2 switches on the handle inside the cabin, and those are the ones that Colleen was talking about, the follow-on cable. They're mounted on a plate that moves when the flaps move. So when you move the handle down, there's like a cam that engages the switch. I'll call it the front switch, the forward switch is closest to the firewall. And when that switch engages, it applies or allows power. So you kind of have to follow me here. I'm going by memory. So let's see, from the circuit breaker, a wire goes to the aft switch on that lever. It doesn't go through the switch. That's just the place where it connects. Okay. So there's 2 wires at that terminal. Goes through a couple of connectors before it gets out into the wing, where it then goes through the down limit switch, because that's the direction you're going. And that switch is closed because you're not down limited. And then it goes back up all the way back to your flap lever to that forward switch that you have now engaged by pushing the lever down. So you've got 2 switches that it goes through and one that it makes a flyby. So you've got a lot of connections in there, not to mention switches. The switches are usually pretty reliable. So when all this begins to happen, when the flaps either get to the position that you've selected, whether it's 20 degrees, 10 degrees, or full down, that cam moves, and the switch, that forward switch that was engaged to make everything start, the cam moves and allows that switch to open. So the flaps stop moving. The down limit switch out in the wing doesn't come into play unless you get all the way down. And when they're rigged properly, the switch on the lever and the switch in the wing both open at the same time when you go to full down. Gosh, that was a lot. Anyway,
Yeah.
sorry. But so there's 4 switches but there's a lot of connections. And the most likely thing is that you've got loose connections somewhere. And remember, those 2 switches on the lever are moving. So you've got a whole bunch of wires. It's like 7 or 8 wires all connected to these 2 little bitty plastic switches. And they have to move up and down. And there's the co-pilot's left knee really likes to hit this a lot. So the first thing that should happen is somebody goes and actually manually touches those terminal ends and tries to move them and find out which ones are loose. And then out in the wing, do the same thing. It'll be the switch at the down limit switch, the wires there that you're going to be looking for. That would be the first thing to check. And
because that switch might be open and it's preventing the flaps from extending, is what you're saying.
the switch or the wire's loose because it's intermittent. So
Sure.
Probably not looking for a switch. Now, it could be, sometimes you think the rigging on the switch, but it won't be the down limit switch because the actuator is at the up limit switch when you start. Oh, but that is actually a part of it because when you start the flaps moving, I'm glad you said that. I have to close my eyes to think about this. Okay. The up limit switch is providing a ground to the motor. All the circuit that I just told you about is providing power to the motor. The ground to the motor is then provided by the up limit switch. And as soon as it comes off the up limit switch through a series of connections through one of those 2 switches up on the lever, it continues to provide a ground even after it is tripped when the thing moves, when the whole assembly moves. This is really easy to talk about in class when I have pictures. It's kind of hard to do in my head.
If the flaps will retract fine, then it shouldn't be a ground issue. You said flaps.
It won't be a ground, not like the ground terminal, but the ground has to go through the up limit switch. So there's connections there that I'm talking about. A loose connection on the up limit switch would inhibit a proper ground for the motor.
Yeah, but if the flaps always retract, that up limit switch should always be working because it's always providing a ground.
Oh, I see what you're saying. Yes, that's true. Because
your head is probably about to explode here.
Mine exploded 10 minutes ago.
Let me tell you what I would have told you if Paul hadn't jumped in there with this 45-minute discussion of how the flap system works.
Okay.
And if you look behind the instrument panel where your flap lever is, there's this plate with micro switches on it that Paul described that moves up and down with the flaps. It's moves up and down with a flap follower cable. There's a big bunch of wires connected to those switches. And every time the flaps go up and down, that wire bundle flexes.
Mm-hmm.
So if you have an intermittent problem, it's 95% probability it's right there, because nothing else in the system flexes or vibrates a whole lot. But that bundle of wires that goes to the two micro switches on that movable plate that's back in the flap select lever assembly, that bundle flexes up and down every time the flaps move. And so it's really easy to have even a wire that fractures inside the insulation where you can't see it.
But he did say that his mechanic fixed it one time by opening up the flap motor panel and
I know he said that,
Is that
but I don't believe it.
It's coincidence. That's what you're saying.
That's the 5%. I said with 95% confidence. I left myself 5% wiggle room. It's going to be right there.
I agree. Yeah.
In that wire bundle that goes to those two micro switches that moves up and down every time the flaps move up and down.
And it's such a joy working back there, I have to admit. It's so much fun cramming your hand in there and trying to get a screwdriver.
And the way you diagnose those problems is you go back and you wiggle that wire bundle. And then if you can get it to happen, then you cut a whole bunch of tie wraps and start wiggling individual wires until you figure out which one you have to wiggle to make it stop.
That's why I was commenting about the engine not running. The reason the problem doesn't occur when you're testing it in the shop is there's no vibration.
No vibration.
As soon as you start the engine or go fly, there's all these vibrations. So one of those screws that holds the terminal end onto the switch, if it's loose, you look at it. If a mechanic just looks at it, says it looks fine, that's not troubleshooting it. You actually have to touch it and make sure that it feels good. Matter of fact, when I get in there, just as a course, because I'm there, I will back a screw off a half a turn and retighten it. And I'll just do all of them, just because that in the world of electronics, that will reduce the resistance at that connection. My whole purpose in the big, long explanation was trying to get across to you that this stuff goes through all four switches. Mm-hmm. So it could be pretty much any of them.
Switches almost never intermit. They'll fail,
but the connections,
but they won't heal themselves.
Yeah.
Mm-hmm. So but it's almost certainly a connection or a broken wire.
Yeah. The ones down at the selector, I was talking about the co-pilot's knee likes to hit those. I have seen those. The switches they're in plastic casings. Mm-hmm. And they can actually fracture. So don't be surprised if you find a switch that's physically broken. Normally, that's a more hard failure than an intermittent.
That wouldn't heal itself, probably.
But so go around, touch wires, look for connections. That's going to be your first thing. And if that doesn't fix it, find somebody that knows how to use a voltmeter and read a very simple wiring diagram that's in the service manual.
Mm-hmm. Yeah.
And then come to class, and I'll give you the full-on 15-minute explanation.
Well, you should do the class anyway. I think as a new owner, you would really enjoy Paul's 182 class.
It is a lot of fun.
Yeah.
I have fun. The people in the class don't have fun. It's just someone. So I got a complaint once. It was in the 210 class, which is 3 days, because people will say, it's like the proverbial fire hose and all that. And one guy said it felt more like waterboarding. So
there weren't enough donuts and coffee, Paul.
Apparently something. I don't know. I wasn't sure if that was a compliment on the content or a complaint about the delivery. Whatever it was.
Yeah.
Oh, and because Luke's failure is always in the extend direction, not in the retract direction, that exonerates about half of the wires. So
yes,
it helps you.
But they all congregate at the same places. So you're just going to go where you see a switch, you're going to go check for loose wires.
Just wiggle around.
Okay. Yeah, sorry that answer was about a 1 minute long answer and it took 10.
No, it's fascinating stuff. I do appreciate it. Thank you.
Good call.
Well, yeah. Thanks and good luck with that. And hopefully it'll be a pretty easy find.
Well, I appreciate you all. Hey, thanks again for your time.
All right, Luke.
Sure. Take care.
Bye-bye.
All right, it's time for letters. A couple of good ones as usual. And actually, both of these have to do with the mechanic shortage, which I think we talked about the last time or the time before. First from Randy, he said, I listened to the last podcast of 2024 yesterday, enjoyed it as always. Referenced the discussion about finding qualified young people for the A&P world. The speakers were trying to find the right words to describe such a person. I did not hear, but would add, intellectually curious and analytical.
There you go.
Yeah.
So there you go.
Diagnostician. Yes.
Those are good words.
Overthinker.
Overthinker. Yes. Absolutely.
So Paul, next time you have a job posting, you can put in intellectually curious and analytical wanted.
You know, there are some mechanics that wouldn't understand what those words mean. So it would be more of, that doesn't make them a bad mechanic. It just makes them not as well read as they should be.
It's not like you're showing a weakness to be curious. You're just open to suggestions and
Yep. Okay, so Robert has a comment about this. He said the brain drain has been going on for quite a while, but really stands out after all the retirements due to COVID. There used to be a 5-year experience requirement in the airline industry, and that is completely gone, and it shows.
Wow.
Trying to put the tribal knowledge into the maintenance manuals is difficult, if not impossible, for the older model aircraft. The type clubs were always a great resource, but they are typically closed off to the maintenance side behind a paywall, and there are too many of them for an FBO to be subscribed to all of them. Oh man, he's getting revved up.
Yeah.
The old guys are retiring out. There's no good way to transfer their knowledge. So much has to be learned by doing. I have used the computer-based parts changing instruction programs in class, and they don't show you what you need to know to get to that last nut or bolt. It took me many years to learn sheet metal, and much of that time was spent in self-study because nobody teaches everything about it, just enough to get you started. Reading through the various SRM chapters, Boeing specs, etc., make it really difficult to get a hold of. Avionics has been similar, although AEA, he says, has good resources.
They do.
The manufacturers don't like giving out a whole lot of information, with Garmin being one of the worst. The best training I see, he says, is an apprenticeship program like Lufthansa, where you get hands-on real-world learning, training from manufacturers rather than this is how we do it on the job sort of training. Curious about that.
It's a great letter.
Yeah. He's obviously, or apparently, more in the big iron world.
Yeah, that's okay.
And the training from the big iron world is different. He was talking about getting training from Lufthansa or manufacturers, Boeing, Pratt and Whitney, that sort of thing. And that's great. In the small airplane world, it's interesting, the training that you get from manufacturers Textron doesn't have any training for the small airplanes, but Cirrus, Continental, and Lycoming, very little of that training is from a maintenance standpoint. In other words, how to maintain the airplane. They're real good at telling you how it's designed, how it's built, how it's manufactured, how it works. But in the world of maintaining, they're way more about, let's change this part, and here's how you take the part off, and here's how you put the part on. Troubleshooting is really not in there very much. I've been to the Continental engine class twice. I've gone through all of the training that Cessna had when they had training. I've gone through the various Cirrus trainings, and some of it is good how to, but the diagnostic part that we've talked about on the show is very little of that being trained. And it's, they can give you a troubleshooting chart, but that doesn't train your brain how to think that way. It's just another checklist to go through. And you've got to understand the system.
Well, so they teach you how it's built and how it works. That's the foundation. But from there, you need to anticipate, if I had this sort of error, how would I see it manifested? And
Yeah.
how could I test
Yeah.
for that?
How can I
But-
test for it?
Yeah.
Yeah,
That's kind of
there are two separate components that are required to be good at a good diagnostician. One is systems knowledge, and the other is I don't know how you put it, but a troubleshooting mindset somehow. And the troubleshooting mindset, if you can troubleshoot plumbing, you can troubleshoot an airplane. The mindset is kind of universal. The systems knowledge is specific to the thing
Is
you're
learned.
troubleshooting, and you have to have both of those.
yeah.
So this brings up actually another letter, which this one's going to be long, but you'll have to indulge me because I love it, and I'll summarize it a little bit.
Okay.
Mike, you in this discussion, of course, you mentioned you make the parallel with medicine, right?
Mhm.
Saying surgeons
Always.
are
Yeah.
cutters, and
Yeah,
So this is from
this is from the surgeon.
a surgeon. So
Of course.
this is going to be the other
Takes
perspective. Yes. So he said, master aircraft mechanic, pilot, author, maintenance service innovator, and great guy, Mike Bush, on a recent episode claimed that surgeons are mere cutters. And diagnoses are made by
Stabbed a nerve.
laboratories, pathologists, and radiologists. So in troubleshooting aircraft gripes, the issue is solved only by the engine monitor data or oil analysis or compression results, right? No. A skilled human interprets that data. The data is not the diagnosis, and the data providers are not I'm not going to be able to say half the words in this letter.
Diagnosticians.
Thank you.
Diagnostics.
Diagnosticians. Thank you. In medicine, a differential diagnosis is formed from symptoms relayed by the patient, signs found on physical exam, and standard screening tests. The differential diagnosis list should include all reasonable underlying diseases which explain the symptoms, signs, and initial screen results. Only then, the clinician, the surgeon in this case, orders various further appropriate specific tests to rule out or rule in candidate diagnoses. These may include radiologic studies, biopsies with pathology, further lab investigations, and so on. When the differential list has been narrowed to the correct diagnosis and confirmed with acceptable likelihood, appropriate therapeutic options are discussed with the patient. So he goes on, and I'll stop it here, but he basically goes on to say general surgeons and surgical subspecialties have the longest, broadest training of any specialty in medicine. So he feels like they are actually the best diagnosticians.
Not just cutters.
So
Not cutters.
I'm not laughing at what he said. It's just except that somebody hit a nerve somewhere and
Somebody.
somebody. So I had lunch with a neurologist and we were talking about, I don't want to say too much because he probably listens to the podcast, but so we're having lunch and somehow cardiologist came up and he said, they're not all that. And I'm like, what do you mean? He said, well, it's three nerves and a muscle. I mean, how much can go wrong?
Oh, wow. Nice attitude.
Wow.
Yeah, he was explaining. I had
You're saying that the cardiologists are overrated, but the neurologists are the king of the hill. Is that
he was saying they're kind of self-overrated, I think, was his comment. Because I was having a regular kind of heartbeat, and he was saying, well, it's just this nerve. This one times the heart, this one, and the second one, and the third one.
I don't think that I ever suggested that surgeons are just cutters. But what I did suggest is that, in medicine, the diagnostic process typically starts with somebody like a radiologist or a pathologist who gathers the data necessary in order to do a differential diagnosis. And of course, part of it is also the clinical interview, which is where you're asking the patient for description of his symptoms, but that's typically fairly inaccurate information compared to hard data that you would get from blood tests and radiological studies and stuff like that. But the point is that the diagnosis has to start with gathering as much data. And what I always rail against are mechanics that that address a squawk by immediately attacking the aircraft with tools rather than starting at the data gathering.
Yeah, skipping the data. It just
Yeah.
well, or they'll take whatever data is presented to them. And one of the reasons I love the TV show House is he would say all patients lie. And,
and everybody lies, is what
everybody
he said.
lies. Yeah.
Yeah.
And when the airplane owner comes in, and they don't intentionally lie, so there is a difference. But they don't give you all the information, not because they don't want to, but because they don't
see what they
understand
see, or
Yeah.
And so you have to begin extracting the information from them. Sometimes that's terribly difficult to do. And when they come in, it's like, well, I don't know. I didn't notice that. I didn't see this, didn't see the
it's
other.
And
that's
it's
where you start.
especially true if they're describing symptoms that
scared them.
were highly stressful.
Sure.
Yeah.
Oh yeah.
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 That was even worse.
Because
Yeah.
then their recollection is almost
Way off.
It's just like a witness at a crime scene.
Yeah.
It's been demonstrated that they don't see certain things, and you
Yeah.
can't just count on that witness to give you the
Yeah.
full information.
The eyewitnesses are the worst.
Yeah.
Yeah.
That closed.
anyway.
CCTV.
I'm glad we have some surgeons listening to the podcast.
That's awesome.
Yes, and I respect what they say. And Mike
and
sometimes does.
I certainly agree with everything that was in that in that letter.
I will say, Mike, you might have gotten an invitation at the end. He said, I think Mike would enjoy following around a general surgeon for a week in clinic on rounds or in the OR.
I would.
I would. That would.
You want to go see some people
Absolutely.
get cut open? Then I think, yeah.
Well, let's see if we can set that up. I don't know.
Yeah.
That sounds interesting. Yeah.
I want to participate in replacing some knee joints, and stuff
Organs.
like that.
Organs.
Yeah, mechanical
Yeah,
stuff. Something where I can get a hammer out.
Let's all scrub in. Come on.
There we go. We can
Sounds
do it.
Great.
We should have the podcast in the OR somewhere.
You guys can operate the scopes, right? You're a board scope.
that's
expert,
right.
So it's like
Yeah.
you could, here, I'll take the camera. Give me that job.
Maybe
All
maybe we'll get some invitations out of this.
Who knows?
great.
All I can hear is Weird Al Yankovic's "Like a Surgeon." I just
Our next question is from Blythe, who's trying to get into the deepest nooks and crannies, which I'm told is something to do with an English muffin. Surely you're not calling about English muffins.
Paul is a biscuits and gravy guy. He
That's
would
right.
Yeah,
And
I got
not English biscuits. We're talking American Southern biscuits.
Talking about cat head biscuits.
yeah,
Yeah.
gut
So
bombs. Yeah.
All right. Where are you from, Blythe? You seem to know a lot about this.
I'm from Georgia, so you.
Oh,
and I
good man. I'm
we're
sorry.
birds of a feather.
I missed the G on the hat.
There you go. Yeah,
My
yeah.
apologies.
Put it on just
Oh.
for you guys.
So Blythe and I are speaking the same language here. We got it going.
I smell what
Okay.
you're
Well,
stepping
Georgia
in.
is
Well,
like Eastern Tennessee, right?
He smells what I'm stepping in. Hey, we're going to have you on the show more often.
Yeah.
I got just enough humor, I think, to make myself sound SMRT, but I don't know. Jury's still out. So anyway,
okay.
I fly. Well, I co-own with my brother a 1964 Cessna 150 that I was taught to fly in. Probably 20 years ago.
That's a D model, isn't it?
That is correct. Yep.
Yep.
It's the first year of the straight tail, but still had, or first year of the Omnivision, but still had the straight tail.
Straight tail. Yeah.
Yep. And it's been a fantastic airplane. We recently have resurrected it, is what I'm calling, from it. It had sat in the hangar unused for a while. And as we were resurrecting it, I found dirt daubers nests everywhere. I mean,
wow.
they were just, I remember the most notable one I can think of is when I removed one of the interior baggage panels. It was enveloping the flap drive cables.
Oh wow.
I mean, bigger than my fist. It was fantastic. We had so much fun popping them all out of there and throwing them across the airport ramp. I got that one, and then I fly and manage for an older gentleman, a 172, a 69K model that actually he keeps in a barn on one of his hay fields. So, I mean, it's truly grassroots flying. And as you can imagine, with a dirt floor barn, there are just dirt daubers nests everywhere in that thing, too. So much
The
so
dirt
that,
dauber is that synonymous with a mud dauber?
that is correct. Yep.
Yeah,
It's a wasp,
insect.
right?
Yeah.
It's a wasp.
Right.
Yep.
Right. Yeah, but they don't sting you. They just build really annoying dirt nests.
I don't think we have those in California.
Well,
I've heard of them, but I've never seen
Yeah.
one. Yeah.
Points for California. Y'all come out to Georgia on the farm, and I'll show you.
Do you have chiggers too?
We
Oh
do.
yeah,
Oh,
ticks
yeah.
and chiggers.
Yep.
Never
yep,
seen
yep,
those. Okay.
Yep. Well, come on out. I can
Well,
introduce
you
you to
don't.
them.
Yeah, you don't see chiggers until they've planted themselves inside you.
Yep.
Ew.
Yep.
Yeah, yeah.
Huh.
Ooh.
They're easy to get rid of though. Just nail polish over the site.
No, I'll give you some scorpions if you want. We got those here.
Ooh.
No.
I think I'll hold off on that.
Yeah.
Anyway. Okay, so we got
as we're going through and all the inspection plates are off, and as I'm finding them, I'm removing as many of these nests.
Is this aeronautical or entomological? I'm trying to. What are we dealing with here?
hey, we cover a broad range of
You gotta
subjects.
let me
We're
segue.
at the boundary line between.
We're liberal arts here on the show. Yeah.
Liberal arts.
Well-rounded education.
Yeah.
That's right.
So obviously we remove as many nests as we possibly can while inspection plates are off. But I know that just from the nature of these things, that there are as many nests that I cannot see as ones that I have removed. So being a card-holding member of the Overthinkers Anonymous Club that I've heard you guys reference, I lay there and think about what do I do about these nests that I know that are there that, hold moisture because they're mud, dirt, whatever you want to call them. Possibly cause corrosion. And I mean, I'm flying a 150, so every extra ounce that's in there, I want out.
Yeah.
I have an
I'd be more worried about the corrosion than I would about the weight.
Right.
Well,
Right.
so actually the corrosion is a part of a possible solution.
Okay.
So dirt daubers don't like to build nests on things that are lubricated.
Oh.
Okay.
So if you
Slippery.
have the airplanes fogged with Corrosion X, and during annual, when you have all those panels off, lubricate. Well, you can lubricate with Corrosion X or ACF 50. It's not a great lubricant, but it's also it will lubricate. Or get something like Tri-Flow and all of those flight control cables. You can just drizzle Tri-Flow or LPS2 up and down all of those cables on your bell cranks. If it's steel, if it moves, spray something on it or squirt it with something, as we say. And the dirt daubers, it's just such a slick surface that they have a hard time getting the mud to stick to it.
Okay.
It's just a general, it's not a repellent, but it'll reduce it a good bit. And don't forget, because you haven't looked yet, and you may not want to, but when you take the two covers off of the tail cone above the horizontal, where the horizontal and the vertical fin come together, and you take a mirror and you look up the vertical fin, they really, I don't know how they get in there, but they love it.
Oh, they can find their way into anywhere.
Yeah, they get into anywhere. And don't forget the flight controls. You want to spray inside the rudder and the elevator and the ailerons and the flaps.
Could they cause imbalance in the flight controls? Are they they don't weigh that much, right?
Oh, they weigh quite a bit, but they don't want to get back into that small area where the skins wedge together. They seem to like to get into more open space, it seems to me.
Near the leading edge.
Yeah. Yeah.
Yep.
So I don't know that that's a fix.
Hey,
but
I got a kind of a weird thought, but I don't know anything
surprise
about mud daubers, but I've had some problems with various kinds of insects getting into various sorts of machinery, like my gate operator and stuff. And one of the things that I've discovered is effective, and I don't know if it'd be effective here, is to toss some mothballs in.
Okay.
I probably wouldn't do that like under the floorboards because it would make the cabin smell funny, but it probably would work in the wing and wings and the rear control surfaces. Maybe throw some mothballs in and try to discourage them from coming in the first place.
Yeah.
Good to know. So that's quite literally mothball.
It's just smelly.
I wonder if mothballs. Wonder how they do with laying right against aluminum. Well, you're going to have it fogged with a corrosion inhibitor, so just toss them in there.
Yeah.
And check on them once in a while.
Right. Yeah. We got the 172 fogged last year, and that'll be on the to-do list for the 150 this year. Our mechanic's fantastic.
What are mud dauber nests soluble in?
Water.
Water.
Are they water soluble?
Yeah.
That's part of the problem I find them is the 172. I cannot figure out where the heck it's coming from. Is if it sits out on a ramp somewhere and gets rained on, it's gonna have belly water. And I have to go and
Oh,
take
so
the
you've
and
got
clean up
you've got
if
drain
needed.
holes that are plugged.
Yeah.
Probably by mud daubers.
Yes, I do.
Well, and the
Oh.
belly's probably full of 50 years of grease and oil.
Not
And
anymore.
Oh, good. Because
Oh, wow.
contrary to common belief, that grease and oil in the belly is not a corrosion inhibitor.
Right.
So you want to be sure those drain holes are open. And,
Absolutely.
And so not just fog the airplane, but get out that spray can of something and spray all those control cables and pulleys and pivot points. And if you miss and hit other things, it won't hurt a bit.
Okay.
Yeah.
Good to know. Yep. Yeah. So we'll have it fogged with ACF 50, and then I've got Tri-Flow, Corrosion X, LPS 1, LPS 2. I've got all the good stuff out there.
You are well equipped.
And if all that doesn't work, there's always the flamethrower option.
Do those mud daubers, do they get angry and sting you or stuff? If you
No, they can't sting like a wasp does.
they
So
don't.
Interesting.
Okay.
Oh,
yeah, I can be pretty brave when I take those on.
oh.
But you have
Wow.
to have a good southern trained eye to spot the difference in a wasp and a mud dauber, because if you
miss.
you'll regret it.
It's kind of like the difference between a bumblebee and a carpenter bee.
Right.
Okay.
Yeah.
Okay.
One of them has a yellow dot and one of them doesn't.
Oh.
And one stings and one doesn't.
Yep.
Oh.
Or it's almost like a snake. If you got to get close enough to see its eye type, you don't want to be that close. You really don't want to be that close.
Flamethrower. I'm telling
There
you.
you go.
Propane torch.
So in this order, we've got Mike telling me to mothball it, and Colleen just telling me to burn it to the ground. You guys don't like bugs out there in California.
Hey,
No, we don't.
you get the best advice on this show. Let me tell you.
Absolutely.
We're giving you multiple tiers of
You take your
First-
pick. It's really up to
first
you.
you corrosion exit, then you mothball it, and then if all else fails,
Light it up.
call Colleen.
Light it up.
Light it up.
You guys give me my expert witness at the at the hearing.
Yeah, but just make sure your insurance is all paid up before you do that.
There you go.
Yep. And then if we have
boy.
time, I've got 1 second question about the charging system on the 172.
Oh, now the first question was free. The second one we charge for.
Okay, I think I got 50 cents.
Okay, that'll do. That's twice as much as I was going to ask for, but go ahead.
Oh, we'll see. So I've been having some charging issues on this airplane, and just a little bit of background. The owner put a 180 horse 0360 conversion in it back in 1991.
Nice.
Pinyin?
Yeah.
No, it's the airplanes.
Airplanes. Okay.
So it got the 200 weight gross weight increase with it, and it's got 1,005 useful loads. It's a
cool.
fantastic.
I've
airplane.
flown an airplane like that. It is. Yeah.
Yeah, it's the best performing 172 I've ever flown. I'm working on it to get an engine monitor in it.
Mhm.
There you go.
Yeah,
Now, here I was thinking he put that engine in the 150, but
No.
never mind.
And then I'd just be able to sit on the ground and make airplane noises because I'd be overgrowth sitting on the
Yeah,
ground.
you'd be able to hover in ground effect. That's
That's exactly right. Yeah. So anyway, that was the last time that it had the alternator and voltage regulator off. Had issues with it. Battery would get low. And I'm out there on the farm getting ready to fly off this crest trip. And so what does a good old farm boy do? He chalks the wheels, and goes out there and then just hand props it and let's go. Right?
Okay.
Mhm.
It is yellow like a J3, at least. So over time, of course, that heavy charging rate from the alternator damaged the battery. But the really interesting thing about this charging issue in and of itself was that when the ammeter shows a good charge like it's supposed to, and when you hook your voltmeter into the back of the bus bar and ground it there on the seat frame, it would show greater than nominal battery voltage.
How much greater?
It would be, this has probably been close to a year ago that this started. I would say 5 or 6 tenths higher than nominal battery voltage.
So it showed 12 and a half?
Is this a 12 volt
That's
system?
not.
It is a 12 volt system.
Yeah, it needs to be 13.8 or 14.
Yep.
Yeah.
Right. Yep. So I'd come right off the charger, and it'd be nominal battery voltage would be 12.7, go fire it right up, and then it'd be putting out, 13.4. something like that. So I was never satisfied. Anyway, fast forward through all that. Go through the maintenance manual of trying to diagnose it, and we have slightly high resistance across the field windings of the alternator.
How much is slightly high? Over
I think
5?
the maintenance manual calls it 5 to 6. I think we had somewhere in the neighborhood of 8 to 9.
Yeah. Okay.
So it's not
slightly
outrageous, but it's not, out of the realm of possibility either. And so through the advice of my mechanic, it's like, all right, on the fact that it's ever so slightly high, brushes may be starting to get worn. Who knows what's happening with the field windings in there, as well as the fact that the alternator and voltage regulator had not been replaced in 32 years.
Okay.
Let's replace the alternator and voltage regulator, because we had also ohmed across the field wire, and it was at like 0.2 of an ohm. So it was in great shape. So we do that, and that fixed the problem for a little while, but it never sat right with me that the maximum voltage we could get out of that thing would be about 13.6, whereas the manual called for 13.8 to 14.1.
Yep.
And he just said, it'd be all right. And I'm like, it's charging.
It'd be all right.
But yeah, it's not charging to capacity.
Yep.
So if you ever
Can't you turn up the regulator?
No, the regulator's, it's a Lamar solid state that's not adjustable.
Okay.
So that was also another fun one, trying to go through the maintenance manual and figure out, how do I take the cover off this thing and observe the points when there are no points even in the voltage regulator? Because the maintenance manual is written.
But it's not adjustable.
Well,
It's
some
not.
of them have an adjusting screw that they don't want you to know about.
Oh.
And if you press your finger around on the top of it where the labels and stuff are, and you find a spot where it sinks, indicating there's a hole underneath it.
Yeah.
There's an adjusting screw underneath that.
Okay.
Don't tell anybody I told you about this.
Okay.
And not all of them have it.
Right. Okay. Good to know. Yeah, and this one, the cover is riveted on this voltage regulator, so there's no removing the cover. It's you take the whole voltage regulator off or nothing, theoretically, until I learned Paul's new little trick.
Is there a Zevtronics
Yes.
version for that?
There is.
That would be even better.
Well, here's what we did. So the saga continues on. These parts are now under warranty from Spruce, which thankfully is only about 45 minutes from my house, my car. So I get back over there, and we swapped the alternator. Well, we pulled it back off, and lo and behold, this alternator's got slightly high resistance as well. What the heck's going on? So we swapped that out with a brand new one he had sitting around the shop, same exact scenario. So put the old alternator back on, and so we're just part swapping to figure out where the failure is. So we do the same thing and put a Zevtronics voltage regulator on there. Same exact problem. And so we fault isolated.
Did you check your voltmeter to make sure it was?
we have
I was thinking the same thing.
3 different voltmeters.
Okay. So I have a thought for you, but go ahead and finish your explanation.
So after changing the alternator, the voltage regulator, fault isolating all of that, we triple checked resistance across the field wire and whatnot. We still had low voltage, and it was particularly low, of course, when you had the airplane loaded up with all the lights on, run the electric flaps, things of that nature.
Yeah.
So I will confess that since I wrote Ian about this, we did figure out what the issue is. But Paul, I want to hear what your thought is.
It's one of those deals.
One of those deals, trying to make me look bad.
It's a trap.
No,
It's a trap. Well, so the first thing that comes, it's pretty cool that you had a voltmeter out and you're checking resistance because you're actually troubleshooting. So you get big points for doing that.
Thank you. If I lose my medical, I'm coming to Tennessee for a job.
Oh yeah, you come on.
Oh, he'll give one to you.
Yeah, no problem.
Yeah.
But you've been troubleshooting everything on the forward side of the firewall, and there's an aft side of the firewall component as well.
Like where are you going?
So you start with the 5 amp circuit breaker, which goes to the alternator switch, which you have a single switch for battery, correct?
Correct. There's not.
But you still, half of it is for the alternator. Did you, in the process of putting these new regulators on, especially the Zevtronics, did you take care and get rid of the overvolt relay, or did it have one?
Doesn't have one that I know of, because there's no overvolt idiot light.
Okay. So once it goes through the alternator switch, let me think on yours. I haven't looked at your wiring diagram, but the point is the resistance from including the 5-amp circuit breaker through the 5-amp circuit breaker, through those connections, through the alternator switch to the regulator. That line is one that I would want to pay attention to.
There's also the
And those-
ammeter in there and the shunt for the ammeter.
Yeah, and that's
Which-
on the output of
he's
Of the
thinking the
alternator.
field circuit. Yeah.
Oh, okay, you're
Yeah.
doing the field circuit. Okay.
I'm going for the field circuit.
He
but-
said the
And
5 amp.
those rocker switches, the master switch, sometimes they are problematic, but only under the vibration of the engine
Yeah.
running. You
Uh-huh.
you ohm them out statically, and they'll seem fine.
Right.
But then they wind up not making good contact under vibration. So
The way I get around that is hook up the ohm meter on the field line at the regulator and then at the bus bar.
Okay.
Mhm.
And then
Yeah,
I'll trip the
let's skip
switch.
everything. Yeah.
And every time you cycle that switch, it should come back to the exact same 0.5 ohms or
Right.
0.6, whatever it is. If it changes, or if you wiggle the switch and you can make it change, then you're going to have the problem like Mike says. The other thing that I will do is, because you don't have a pullable breaker, or it didn't originally have a pullable 5-amp breaker, is I'll short the breaker to ground and make it trip. And
Mhm.
that'll break a lot of the oxidation off the contacts.
Yeah. Yeah. Actually, I've gone through my breakers and popped them all to see if
Yeah.
they popped at the right voltage, current. Yeah.
Yeah.
Right.
Because
And-
they get old, and even better, replace them.
Yeah, even
with
better.
pullable breakers.
Pullable
yeah.
breakers. But if you go through and trip them like once every 20 years or
They'll
30
exercise
years,
them. Yeah.
just exercise those. You'll be amazed at how much brighter the nav lights are.
Oh yeah.
It's
Yeah.
immediate.
these are the non-pullable breakers you're talking
Yeah.
about.
Yeah,
The
right.
originals. Yeah.
I don't know if it's just me, but it's always seemed to me that those things should never have
Yeah.
been approved in a certified airplane.
Yeah. No way.
The,
I
the-
like
the
that.
notion of a circuit that you can't turn off.
Well,
that
some of
doesn't
them are
make sense.
switch operated, so I guess they figured the switch is the
Yeah.
operable part. But
Yeah,
I
think
agree.
I think they were trying to save money somewhere along
That's
the
probably
line
true. Yeah.
back in Wichita.
That's
So-
a good case for that.
What did you find out, Blythe? Did we get even close?
No.
You did. I like where you went with the other side of the firewall. And so for some more fault isolation, the electronics guy of my A&P's shop said, well, let's see if we can alligator clip to the input of, and I don't recall there being a 5-amp circuit breaker on it. It's got one 60-amp circuit breaker.
Well, that's
No,
the
there's-
alternator output.
That's the output
Right.
breaker.
That's
but
the output. There's
the
a
field
5-amp breaker on the
There is
field.
a 5-amp field. Okay, I just have to overlook that one then. So we alligator clipped to the input of the 60-amp output alternator breaker, and lo and behold, we had perfect voltage.
Yeah.
So you had high resistance on the 60-amp breaker.
It
Which
was
is
losing-
expensive,
It
unfortunately.
was losing almost a volt
Yeah.
through
Yeah.
that 60-amp output breaker.
Yeah.
Can
Yeah.
you?
Holy
were you able to
mackerel! That
find
thing
a
must have been
60-amp?
hot.
Yeah.
Say
What's
again,
that?
Paul?
Well, I was going to say, like Mike said, it must have been hot if it had that
Yeah.
much resistance. Were you able to get a 60-amp, or do you have to go
Yeah,
to
they're
a
hard
50?
to find.
They did get. We found a 60-amp, and it's been
Wow.
replaced, and everything is good to go. I mean, my
Awesome.
mechanic is, you can pry him from my cold dead fingers. He's a jam up guy.
You know what?
Yeah.
I'm just going to hire both of you.
Yeah.
Okay.
Yeah.
Well, I was impressed to hear that his shop had an electrical guy, because
Yeah.
most
Yeah.
shops don't have anybody who's not scared of electrons. So
Yep.
That's
Yeah,
really
this
good,
guy,
too.
I don't know that he would admit that he's not afraid of electrons or not, but he's got the mind for it. I think he may even have some background, at least formal education, if not a degree in it. So,
So
anybody who uses a meter is that he's passed the first test anyway.
At-
well, good.
At the risk of causing trouble for your
Uh-huh.
shop, do you want to tell us who the shop is, or where?
Yeah.
Just what?
I don't think it's Precision Aero. The owner's name is Wade Robertson, and he's in Thompson, Georgia, at Hotel Quebec Uniform.
Okay.
Now he
Okay.
might skin me alive if any more work comes, because he's
Well, that's what I was talking
Right.
about.
Yeah.
If they're willing to get a voltmeter out and do troubleshooting and actually understand how to do that,
right.
that-
You put
that is
them down.
rare. Very
Right.
rare.
He He's
And
an
the-
excellent diagnostician. Absolutely
And
fantastic.
again, I'm trying to train my A&P students. I teach DC electrical theory.
Uh-huh.
I'm trying to train them to not just shotgun parts. It's
Oh,
always
yeah.
the alternator, the regulator, or maybe a solenoid, something like that. But there's wires that connect all these things, and
Mhm.
switches and shunts and circuit breakers. And in these old airplanes, there's corrosion everywhere in those
Yep,
parts.
Yep. And so he actually found a
Think
little
of the
bit of corrosion and a little bit of
Yeah.
heat on the
Yeah.
on that inbound on the input wire to the output breaker. And
Yeah.
but there was enough slack that we could just strip that off, cut it off, get some fresh, and hook it back to the new breaker. And
Oh,
Cool.
you
Oh,
saw
little-
the
Well,
terminal
you
end
mean,
was
he meant
discolored.
like melted
Yeah.
insulation.
Yeah.
Crispy wires,
That's
crispy.
an obvious giveaway. Yep.
Yeah.
Yep.
Good
Well, and
catch.
we couldn't see any of that until after we had back
Pull it
probed
out.
it in the right spot and figured
Yeah.
out, oh, we're losing a volt through the breaker here.
Well,
So,
good
Holy
job.
mackerel.
Yeah.
Yeah.
Well
He's
done.
fantastic. Like I said, you'll probably hear him from my cold dead fingers.
No, I don't want to be such a mean guy.
Yeah.
I'll just get both of you. I'll
Yeah.
hire him and kidnap you.
Yeah.
My wife, you have to conceal my wife on that one. Good luck, Paul.
Uh-oh, good luck.
We'll get you a house. It's okay.
Well, sweet talk. Wow. Paul's
Oh,
offering
now-
room and board.
now it's
Well,
negotiating seat.
If I did the math right, a volt drop at 60 amps is 60 watts, right?
It's a
Yeah.
bunch.
Yes.
That's
yes.
a lot of that's a fair amount
of
of
power.
heat.
Yeah.
A lot of
IE.
resistance,
Yeah, that'll heat the cabin.
That's like a small
Good.
soldering iron.
Yeah. It was pretty incredible.
Wow.
Yep.
Well,
Good
cool.
catch.
Great,
Yeah.
great call, great questions, and excellent job on the troubleshooting.
Well, I
Yeah.
appreciate the time. I appreciate the expertise, and you guys include me on here. Like I said, it feels like I'm with the rock stars, but at the same time, since y'all been taking me to and from work, I feel like we're part of family too. So
All right.
That's right. We are
Excellent.
family.
Yeah, definitely. And you speak the right language. I don't care
There
what
you
Mike
go.
and Colleen say.
Yeah, I was going to say, if Blythe came into your shop for an interview, all you need to do is listen to him speak for about 60 seconds, and you'd say you're hired. I don't care if you know anything.
And I don't even have to explain to Blythe what all y'all means. He
Hey,
understands
I know what-
exactly how many people that is.
That's the
absolutely.
plural.
But I know when something
could
looks wallered out too.
That's right.
Oh,
All right.
great.
Thank you,
Well, thank
Blythe.
y'all.
It was great to have you on the show.
It was fun
my
talking to
pleasure.
you. Yeah.
Thank you.
Take care.
Y'all too.
Well, that's it for another lively Ask the A&Ps episode. Hopefully you had as much fun as we did, and hopefully you learned something. I know we did. As always, we read all your feedback and we really need all your questions. You can email us at podcast@aopa.org.
See ya.
Bye bye, everybody.